Hey everybody, Mr. G back at you again. This is video number 3 in our little mini series. In this one, we are going to cover measuring current. Again, we are using the Keysight Digital Multimeter 34460A. Again, this procedure can be used with any digital type multimeter. So, current is measured as it flows through something. So we're going to do a couple of different styles of measurement. The first one is going to be measuring the total current flowing into the circuit. So in order to do that, we must turn this into an ammeter. In order for this to measure current, we take our red probe and we put it into the bottom hole. There's I for current, unit is amps. Then we are going to take the black and we're going to put our black in the common like we normally do. Then we have to turn this into something that is going to measure DC current. For this particular meter, DC current is up here on the shift, so we shift and press DC current. And you'll see that we are now measuring a measurement of amps, and we are measuring it in DC, so DC current. So I have my power supply connected up to my circuit. If I want to measure the total current flowing in this circuit, what I must do is I must insert the meter before the circuit to measure that total current. So I will open up the circuit at this point here. So as the current is entering into the circuit, I am going to break the circuit. I will insert the ammeter. So red goes into red, the electricity goes up into the meter to be counted, and then it comes out of the meter and returns our circuit. So in this particular case, my current is 0.175 milliamps. So 0.175 milliamps is the current that is flowing in this circuit. So again, I'll do that one more time. So here is our circuit complete. We must break the circuit because we are going to be counting or measuring the electrons flowing in the circuit before they actually enter. So the electrons now go up into the meter in the red, they get counted, and then they return back. And they flow through the whole circuit and then back to our supply. So again, 0.175 milliamps of current. Now I could also choose to measure the current on the way out. So whatever goes into the circuit must also come out. So I can measure the current on this side. I can measure the total current as it's coming back to the supply. The red probe goes closest to the red. The black probe goes closest to the black. And now I'm measuring that same current as it's leaving my circuit. So it doesn't matter whether you measure the total current coming in or coming out of the circuit, the total current will be the same. Now what if I wanted to measure the current that is flowing through one of the resistors? So I'm going to identify this resistor right here. This is the 10 kilo ohm resistor, and I want to measure the current that is flowing through that resistor. So in order to do that, I must somehow get my meter into the circuit so that the electricity can actually leave the board, go up and get counted, and then come back. So there are two ways that I could do this. I could measure it on one side of the resistor, so I could pull this end out of the board. So I've broken the circuit at this point. I can now insert my meter where we broke the circuit. So now the electrons are going to be counted on their way to that resistor. So I've got 116.9 microamps of current flowing through that resistor. So I'm basically measuring the current as it's coming into that resistor, or I can measure it as it's leaving the resistor. So I'm going to put this back. And as the current is leaving the resistor is over here. So I'm going to pull that in. So the current is going to leave the resistor, go up into the meter, get counted, and then return back to my circuit. 116.96 microamps of current. So each component, you can measure the current coming into the component or leaving the component. It is the same value. So current flows through something, and as current is flowing through something, you could measure it as it's going into the device, or you can measure it as it's coming out of the device, and you will get the same value. So let's do that one more time with the other resistor. So I'm just going to put my circuit back to its original condition. There you go. Let's try this resistor. So I can pull it out in the side that is coming in. I put the red probe from where I pulled it out. I put the black probe to where it's entering in the resistor. And I'm going to get 58.1 microamps in this resistor. I can put the circuit back together, and now I can measure the current coming out the other side of that same resistor over here. So I'm going to break the circuit. I'm going to insert the meter where I broke the circuit. So now the electrons, as they leave that resistor, will go up and get counted and then return on their flow. And again, we get 58.17 microamps of current. So that is how we are measuring current using our Keysight meter. And again, the difference where you put your red probe, the input must be where the current measurement is. So you'll see over on the side that it's measuring amps, current symbol. All of the other measurements that we did, resistance and voltage, this probe was up top where we have voltage and resistance measurements. I hope this helps. Till next time, take care.